Hi, my name is Mike Milheim. I'm the 5G Technical Architect at Keysight Technologies. We're at Mobile World Congress this year doing a demonstration using phased arrays from a couple of our partners. Phased arrays will be a likely application in 5G. We'll see these probably at 28 and 39 gigahertz. What we're showing today is two phased arrays at 28 gigahertz. One of the key things that will make this successful is developing cost-effective manufacturing and test procedures for this. We've been testing phased arrays for quite a long time, mostly for radar applications, but as we move to communications applications, we'll have some different challenges, including using wideband modulated measurements. So the demo that we're going to be doing today will be making measurements with wideband modulated signals. So one of the key things we'll have to overcome is how do we get cost-effective test approaches for these arrays in the communications market. This will be a combination of built-in tests, test modes for larger assemblies, and also coming up with cost-effective test procedures that will validate that the arrays are good without testing every single position. The likely application for the arrays is going to be point to multi-point communication. So this would be like the last several hundred meters of a fixed wireless. Here we see in our example here, we've got one antenna beaming to multiple different houses, and we're using a relatively simple waveform. We're using a single carrier modulation with low peak to average ratio. We're expecting that the antennas will be outside and that the beamforming will pretty much all be set up at the installation time. Now, it's also possible that all of these guidelines might not be followed, and we may be using higher difficulty waveforms, such as OFDM with high peak to average ratios, and we may end up wanting to put one of the assemblies inside and maybe not doing installation by technicians. So all of these things are possible, but are going to be more difficult for the industry to overcome. So let's take a look at what we're demonstrating now. Here we see our 89600 modulation software, and this is our normal software that we're using. You can see here we're demodulating our carrier, which is a 16 QAM signal, 100 megahertz bandwidth at 28 gigahertz. We have a couple additional plots here that we have, which is the position of the antenna, or what the output power was over the different antenna positions. We see on the plot in the middle the output power versus different antenna positions, and on the bottom we see the air vector magnitude at different positions. One of the things that we can see is that across the entire 3 dB bandwidth of the beam, we're seeing very low EVM measurements. So let's go ahead and run one of the tests. Now, and this time we're going to do this a little bit differently. As we're moving the antenna, we're going to be electronically steering it back towards the receive array, and in this case we should see very consistent power and EVM measurements across all those measurements. So let's go ahead and run that test. Okay, let's go ahead and take a look at the results of the measurements that we just had. Since we were measuring and electrically steering the beam back at our receive antenna, we see a much smaller variation in the power level that we measured than we did previously when we were not scanning the antenna electronically. We also see that our air vector magnitude measurement was very flat across the entire band, and it looks like we got one outlier point. Now, in the environment we're working in here, we're not inside using a chamber, so we can expect various reflections that could come up intermittently that might cause inconsistencies in our measurements, and that's probably what we saw here. But this gives you a good idea of the types of measurements that we'd like to be doing with phased array antennas. We're busily working with various companies in this industry, our two manufacturers of our arrays that we have here, as well as several other customers. So thank you for your attention to the video.